Introduction. Father, our home's gate is looking so dull and rough. Yes, son. This gate must be 8 to 10 years old. Father, but why this gate becomes so dull? Son, it's because of corrosion. Corrosion? Father, can you please tell me about this? I don't have much idea about that. Sure, son. Corrosion is a process of slow conversion of metals into their undesirable compounds by reaction with moisture and other gases present in the atmosphere. This gate is made up of iron, and corrosion turns the iron into brown precipitate called rust. That's why it is looking so old and dull. Okay, Father. Now I understand about the corrosion. Father, can you please tell me more about this? Yes, son. To know more about corrosion, today we will study about electrochemistry. Objectives. At the end of this lesson, you will be able to define electrolysis, analyze mechanism of electrolysis, understand Faraday's laws of electrolysis, define batteries, categorize batteries, know about fuel cell, define corrosion, analyze electrochemical theory of rusting, and explain prevention of corrosion. Electrolysis. The process of chemical decomposition of the electrolyte by the passage of electricity through its melt or aqueous solution is called electrolysis. Electrolytic cell. The apparatus in which the process of electrolysis is carried out is called electrolytic cell. It consists of an electrolytic tank which is made of some non-conducting material. Electrolyte, either in molten state or in the form of a solution, is taken in the electrolytic tank and two electronic conductors are dipped into it. The electrodes are connected to a source of direct current. The electrode connected to the negative terminal of the battery is called cathode, and the other connected to the positive terminal of the battery is called anode. Mechanism of electrolysis. When an electrolyte is dissolved in a proper solvent or taken in molten state, it splits up into two charged particles called ions. When electricity is passed, ions respond to the applied potential difference and move towards the oppositely charged electrodes. Thus, cations move towards the cathode while anions move towards the anode. On reaching the respective electrode, the ions lose their charge and form neutral particles. Cations accept electrons from cathode, whereas anions give electrons to anode. Therefore, oxidation occurs at the anode, while reduction occurs at cathode. Products of electrolysis. Products of electrolysis depend mainly upon the following factors. Nature of the substance being electrolyzed. If electrolysis is carried out in the molten state of electrolyte or in aqueous solution, products formed at the electrodes are different. The type of electrodes being used. If the electrode used is inert, it does not take part in the reaction, or if the electrode is reactive, it takes part in the electrode reaction. Then, the products of electrolysis would be different. The different oxidizing and reducing species present in the electrolytic cell and their standard electrode potentials. When an electrochemical reaction is so slow kinetically that it does not seem to take place, then some extra potential called overpotential has to be applied for such a process to take place. Concentration of the solution also affects the products of electrolysis. Faraday's laws of electrolysis. Faraday's first law of electrolysis. The amount of a substance deposited, evolved, or dissolved at an electrode is directly proportional to the amount of electricity passed through the electrolyte solution or its melt. M is directly proportional to Q, where M is the amount of substance deposited or dissolved. Q is the amount of electricity. We know that Q is equal to IT. Therefore, M is directly proportional to IT. It can be written as M is equal to ZIT, where Z is called electrochemical equivalent of the substance. Z is defined as the amount of the substance deposited or dissolved by passing 1 coulomb of electricity through the electrolyte melt or solution. Faraday's second law of electrolysis. When same amount of electricity is passed through different electrolytes, then the masses of the substance liberated at the electrodes are in the ratio of their chemical equivalent masses. Example on Faraday's law of electrolysis. Let's take an example on Faraday's law of electrolysis. Silver is electrodeposited on a metallic vessel of total surface area 900 cm square by passing a current of 0.5 ampere for 2 hours. Calculate the thickness of silver deposited. Let's see the solution. Here given values are A is equal to 900 cm square, I is equal to 0.5 ampere. We know that mass of silver deposited is given by M is equal to ZIT. By putting the values, we get M is equal to 4.029 gram. We know that V is equal to M upon D. By putting the values, we get V is equal to 0.3837 centimeter cube. Let the thickness of deposited be X centimeter. We know that X is equal to V upon A. By putting the values, we get X is equal to 7.67 into 10 raised to the power minus 4 centimeter. Hence, 7.67 into 10 raised to the power minus 4 centimeter thickness of silver is deposited on the metallic vessel. Batteries. A battery that is employed as a source of electrical energy is basically an electrochemical cell, in which chemical energy of a redox reaction is converted into electrical energy. The term battery is used to represent an arrangement of 2 or more galvanic cells connected in series. Essential characteristics of battery are: it should have longer life, the battery should be light and compact, it should be rechargeable, and the voltage should not vary much during the use of the battery. Categories of batteries. The various commercial batteries are broadly classified into 2 types. Primary batteries. Primary batteries become dead over a period of time as the chemical reaction stops. These cannot be recharged or reused. For example, dry cell and Mercury Cell. Secondary batteries. Secondary battery can be recharged after it becomes dead by passing direct current, and the battery can be used over and again. For example, lead storage battery and nickel-cadmium storage cell. Dry cell. The cell consists of a cylindrical zinc container which also acts as anode. The cathode is a carbon rod surrounded by powdered MnO2 and carbon. The space between electrodes is filled by a moist paste of NH4Cl and ZnCl2. The graphite rod is fitted with a brass cap for better electrical contact, and the cylinder is sealed at the top with pitch. The zinc container is covered with cardboard to protect Zn from atmospheric oxidation. The cell has a potential of nearly 1.50 volts. Dry cells find extensive use in torches, transistors, radios, clocks, etc. Mercury Cell. In Mercury Cell, zinc-mercury amalgam is the anode and a paste of HgO and carbon acts as cathode. The electrolyte is a paste of KOH and ZnO. They produce constant voltage of 1.35 volt during their discharge. The cell potential remains constant during its life, as the net reaction does not involve any ion in solution, whose concentration might change during the discharge of the cell. Mercury Cell finds extensive use in heart pacemakers, watches, cameras, hearing aids, etc. Lead storage battery. It normally consists of 6 voltaic cells connected in series. In each cell, anode is made of spongy lead and cathode is a grid of lead packed with lead dioxide. Electrolyte is H2SO4 solution, which is 38% by mass. Sulfuric acid is consumed in the reaction during discharge of the battery, and as a result, the density of acid falls. When the density of solution falls below 1.20 gram centimeter raised to the power minus 3, battery needs recharging. When electrical energy is supplied to the battery from an external DC source, cell operates like an electrolytic cell and chemical reactions take place. But now, the electrode reactions are reverse from those that occur during the discharge of the battery. To increase current output of the cell, anode and cathode are arranged in alternating manner and are separated from each other by sheets of insulating material. Each voltaic cell has a potential difference of about 2 volts. Therefore, to have an output of 12 volts, 6 cells of the battery are connected in series. Nickel-cadmium storage cell. In this cell, anode is made up of cadmium and the cathode is comprised of a metal grid containing nickel oxide. The electrolyte is KOH solution. The cell has a voltage of about 1.4 volts. There are no gaseous products formed during the discharge of battery, and solid products formed adhere to the electrodes, which therefore are reconverted by the charging processes. These cells are extensively used in electronic watches and calculators. Fuel cell. Fuel cells are electrochemical cells in which the substance oxidized is not electrolyte or electrode material, but an externally supplied substance, which can also be used as a fuel in a heat engine. A fuel cell is a device of converting chemical energy of a fuel directly into electrical energy without using a heat engine. A regulated continuous supply of a conventional fuel like hydrogen is oxidized at anode, and a conventional supporter of combustion like oxygen is supplied and reduced at cathode. The cell runs continuously as long as the hydrogen and oxygen gases are supplied into the cell. Fuel cells do not cause any pollution problem. Corrosion. The process of slow conversion of metals into their undesirable compounds by reaction with moisture and other gases present in the atmosphere is known as corrosion. For example, silver gets tarnished, iron rusts, copper develops green coating on its surface, and lead loses its luster. The factors which affect the rate of corrosion are reactivity of metal, presence of impurities, air and moisture, strains in metal, and presence of electrolyte. Electrochemical theory of rusting. According to this theory, The impure iron surface behaves like a small electrochemical cell in presence of water containing dissolved oxygen or carbon dioxide. Such a cell is also called corrosion cell. Pure iron acts as anode and impure surfaces act as cathode. Moisture having dissolved oxygen or carbon dioxide in it constitutes electrolytic solution. At anode, oxidation of iron atoms takes place. At cathode, the electrons are picked up by H+ ions. The hydrogen atoms reduce the dissolved oxygen. The ferrous ions so formed move through water and come at the surface of iron object, where these are further oxidized to ferric state by atmospheric oxygen and constitute rust. Prevention of corrosion. There are many methods for protecting metals from corrosion. Some of these are as follows. Barrier protection. In this method, a barrier film is introduced between iron and atmospheric oxygen and moisture. Sacrificial protection. This method involves covering of iron surface with a layer of more active metal. Tinning of iron. Tin is very less electropositive and therefore it is not corroded in air. When a layer of tin is applied on the iron surface, it gets protected against rusting. Electrical protection. In this method, iron is connected to some more electropositive metal like magnesium, zinc, and aluminium. Using anti-rust solutions. These are alkaline phosphate and alkaline chromate solutions. The alkaline nature of solutions presents the availability of H+ ions, which facilitates oxidation of iron into Fe+2. Did you know? At normal temperatures, iron will not corrode appreciably in the absence of moisture. Electrolysis is the only method of permanent hair removal approved by the Food and Drug Administration or FDA. The first battery was created by Alessandro Volta in 1798. In natural waters, the rate of corrosion generally tends to increase with increase in the velocity of motion of the water over the metal surface. Summary. Let us summarize what we have learnt. Electrolysis is the process of chemical decomposition of the electrolyte by the passage of electricity through its melt or aqueous solution. When an electrolyte is dissolved in a proper solvent or taken in molten state, it splits up into two charged particles called ions. The amount of a substance deposited, evolved, or dissolved at an electrode is directly proportional to the amount of electricity passed through the electrolyte solution or its melt. When same amount of electricity is passed through different electrolytes, then the masses of the substances liberated at the electrodes are in the ratio of their chemical equivalent masses. A battery is an arrangement of two or more galvanic cells connected in series. The process of slow conversion of metals into their undesirable compounds by reaction with moisture and other gases present in the atmosphere is known as corrosion. The impure iron surface behaves like a small electrochemical cell in presence of water containing dissolved oxygen or carbon dioxide. Such a cell is also called corrosion cell.